Hi everyone. I know I'm the last talk, so I'll try to keep it short so that we can get something to drink. But let me first introduce myself. I'm Yoeri. I'm a front-end developer in Bergen. I've been working with front-end for a long time, and I think it therefore is quite wise to first take a step back and to see what we've done in the last, well, what is it, 30 years right now? And I'm going to start with these logos, which a few of them might scare you if you've got to meet some programs made in them. But this is basically what interactivity on the web was for a long time. Starting with 1995, when Netscape, I think, if I have it correct, introduced JavaScript, a new language to actually make something interactive. Before that, you had some nice HTML things where you can start make things moving, or you could add a GIF to a page, even if you had images, but that was about it. And JavaScript kind of changed the game. But this is a time where everything is slow. There is no computing power, there is nothing to do, so the only few things that you could add is make a button or a form a bit better. And people wanted to do more on the web. We wanted to play games, we wanted to have interactivity. So slowly we got Java and Flash as alternatives. You've probably all grown up with some kind of website where you can play a lot of Flash games. I'm guessing that's everyone here. Yeah. Well, have you played those Flash games since? No, not really. Also, Java came around and was kind of terrible on the web, where you had this loading animation and it did really basically nothing. And if you have seen it, Microsoft Silverlight, well, it felt like you were RDPing to another machine that's running some kind of very old Microsoft C# application. Not great. The biggest problem with these three compared to JavaScript is that you are just limited by the design. You don't have direct access to the DOM. You're basically looking into a window to another world, to a window that doesn't associate with the actual website that you're looking at. So that means that if you want an interactive website with more functionality, nicer button animations, that would mean you either had to make it entirely in Flash, which doesn't sound like a great idea either, or you would have these windows everywhere and hope for the best. Interactivity through existing solutions and don't integrate with the DOM. And then we continue with just JavaScript. We finally get better computers, we finally get more functionality on the web, we can start interacting more with the DOM. It turns out that no real browser thought of how to do that, so all browsers did something else. Luckily, then we get jQuery to kind of fix that. Okay, so now we can at least try to edit things there. And it turns out JavaScript is also a kind of terrible language. The syntax just got too verbose sometimes. Again, you had the problem that all browsers implemented differently, so we started introducing other languages like Coffeescript. I think the older programmers might have known it a bit and thought like, yes, finally, a language which looks normal and is a bit easier to use. But it changed. Around the time that Chrome got introduced, a few years later on, we finally started getting the power in a machine, but also the willingness to start doing something with JavaScript, getting away from Flash, getting away from Silverlight, getting away from Java. And it made JavaScript a much better language. And I think almost everyone in the room here would agree that JavaScript nowadays is a usable language, right? Yeah, except that mostly all of you are probably using Typescript instead. Yeah, exactly. So JavaScript is still this kind of weird language, is just kind of there, that we've grown up with since 1995. It was never designed for what we're doing with it today, and the only real reason that it's running as well as it does is because engineers at Google got paid $300,000 a year to try to make it work. And they did. It runs really fast in a web browser, but we're still wasting time, still have a language which isn't really nice that we want to use, and we have no real way of fixing it. Introducing WebAssembly. Because this was very much known to people making browsers as well, that there's a missing link. You can only use JavaScript on the web right now, and we should be able to do more than that. Plus, throwing away so much computing power. Think about when you're writing a native application and when you're writing JavaScript. How many layers there are between your JavaScript running and what the actual computer is doing. Plus that JavaScript has been designed to be in a single loop. So we have to add all kinds of hacks to get some kind of multi-threading working. Not great. WebAssembly tried to make something new, like a universal language which other languages can port to and which everyone can write. A language that is much faster, that is optimized for what the CPU is actually doing. So as raw instructions as possible, while still making a lot of guarantees about safety, usability, and compatibleness. If you look at the design, especially if you read the initial papers on what the thoughts were behind WebAssembly, it had to be safe, as in it should be able to run in a web browser. We can't trust any website you're visiting. Most websites you're visiting are downloading 20 different ads from 20 different sources who you've probably not vetted, and the owners of the website probably haven't either. So it should be safe. It can't escape the web browser. It needs to be open. All browsers need to be able to use it, spec needs to be open, and every language must be able to use it, because otherwise, what's the use? It must be fast, otherwise we can just go back to Typescript, I guess. And finally, it needs to be hardware and platform independent, and I'll talk a bit more about what it means later. So, how can we actually start using WebAssembly? And I've parted this in 3 different ideas on the levels that you can reach when using WebAssembly. And I'm first going to start with the innovator. And I'm going to do some live coding, or show some live code, which is always great during presentation I've seen in the past. Because I have an idea of finally being able to read all tweets again. Like now that this platform isn't really doing that well, Twitter doesn't exist anymore, but there still are these tweets from like 2009 that are valuable for me. So I've downloaded the dataset of 1.6 million tweets, which is way too much for a web browser to handle. Can't even search to it. So I've written this program in Rust, which reads through these tweets and which can actually filter through them. So I've made some kind of function that takes all of the tweets I've gotten in this tweets array. It goes through them all, filters them for this text, searches, and eventually I can query the results to know what the tweets are. But this is Rust. How do I actually get that in my web browser? I could just basically compile it. The ecosystem nowadays is there. Oh, I'm already in the right folder, very prepared. I can just build this code, and this will actually make a JavaScript package for me. And you'll see that it creates this wasm file. And on the browser side, I can now just use this directly, like I would with any other package that you would download from npm. So I have the CEC page here. This literally just imports that package, initializes it. That's the only thing you would need to do for a wasm package to make sure that the runtime gets set up, that you can start using it, and then I can use it like anything else. It's actually part of the web now. So here I do that. I have a file input. I can read the file and just make the CSV data. If we look into this, we'll see this is just some TypeScript code, but it's actually a function that's being called in my wasm file that I compiled here. So let's run this. As you can see, I'm not a designer. At least, even not a designer enough to import some make my website be beautiful CSS file, but at least I made the dark mode, so you can be thankful for that. I can now just open my tweet CSV file, which is 238 megabytes. It will load, and here are my tweets. And I can even search through them. Like, for instance, maybe there was someone talking about refill already in 2009. So if I fill in refill, with almost no delay, I get, well, I got the refill for my prescription today. I don't know if that's what we're searching for, but it works. This is calling Rust code from the browser without any big delays, 1.6 million tweets without you really noticing. That's nice. So what's actually going on behind the scene? How does wasm actually look like? And for that, I can just make a small function, which is easy enough to show. In this case, let's make an add function. Let's add 2 numbers together. And of course, let's make this accessible from the browser. So wasm bindgen, for this case, is for Rust, is a package to make it easy for me. You could do this This is available for basically any language, not like this, but you can write C, you can write C++, Go, C# if you really want to. I don't know, Java maybe, probably not, but... and again, we can compile this. And to see what we've actually done, like how this looks like, let's go to our package folder, and then we can unpack our wasm file. So in this case, this .wat file. This doesn't look like assembly, but this is basically the assembly language for wasm. A lot of calls, all the functionality, and a lot of unreadable machine-like code. And in here, there is my add function created. And it's created under an identifier. So I can just search for that. And it's my function. It gets these two parameters, it adds them together, and it returns that. It's quite simple. It's not exactly what you would expect when seeing machine code, but again, this is not machine code. This is a layer above that, because we can't just start running actual binary x86 instructions on our machine directly. That would be very unsafe. That's it. And now that's compiled, I can also just immediately use it from my page. So if we would import it, if we would call add, I can see that it's in Rust C reader, and I can do add 1, 2. And hopefully it will give me the correct results. So that's the first part. I do want to reiterate, sorry about that. This is definitely not a Rust talk in disguise. I do really like Rust. You should too. It's a great language, but I'm not. This is just because I'm comfortable in the language and I know that the wasm ecosystem is quite good. So I'm using that. But to explain a bit on what it's actually doing, how this is actually working, we should look at this slide. So WebAssembly is running directly in my browser, but it's not running directly against the DOM and our browser APIs. There's still this kind of glue that's there. So JavaScript is calling the glue, which is calling my WebAssembly and going back and forth, because these are two different worlds. In machine code, a string doesn't exist. A string is just a binary blob of data. JavaScript doesn't really care about that. The browser will take care of it, but we need to translate between these two values. So it's not as good as running directly towards the DOM, but it does give some more possibilities for that later on. What about the revolutionary? Because this is just providing some functionality in Rust. And with that functionality, we can, for instance, change the very slowest part of our code to be faster, and that's great. But what if we could actually just write our whole website in Rust? Or WebAssembly, I mean, again, this is not a Rust talk. One of those frameworks is Leptos. And I just want to show you shortly what this looks like. This is it. This is a website written in Rust with WebAssembly. And it's very React-like. You might recognize the idea of components, composability. In this case, this is a framework using Signals, if you're familiar with Solid.js, frameworks like that. But I can just make an input, which has some kind of setter and getter. And it writes my name to this other component that is then using that to get some text out. And I can again just run this in my browser. And to compile. Oh, I thought, okay, I did have the dark mode. Sorry for that. And it just works. And I can fill some other name in, like, hello, my name is Refill, Mikael, I don't know. It just works. And you think, okay, but this is a compiled language. This is going to be much more difficult with development. Like with JavaScript, I'm just used to that everything magically works and gets replaced, and I don't need to reload my browser. Well, in here I can just change some text as well. And it will recompile, of course, but that's quite fast, and it will automatically update. So it's an ecosystem which is already building out over years. And to convince you a bit more about that, we showed Next.js early this morning about server-side rendering, server actions. These are like modern features that we want to use to make our lives easier, to not have to think about forms. These are all available. These just work out of the box. You can make an entirely full-stack application with one single code base using WebAssembly. And that doesn't mean, of course, that this ecosystem is perfect. This is still very new, and bundle splitting is a lot harder. But there are functionalities in WebAssembly that can make that happen. Not a Rust talk. I have shown quite a few Rust frameworks, like Dew and Leptos are both Rust. But there's also, for example, one big one from Microsoft, Blazor. I can't tell you a lot about Blazor, but this is a Microsoft-backed framework which runs entirely with WebAssembly, which allows you to write C# code for the web. Their idea is that now the backend developers can finally start writing front ends. I don't know if that's a good idea, because there's a lot more to web development than just writing lines of backend code, but that's them. And then finally, the last frontier, the madman. Can we take this one step further? So we've written an entire website in Rust. What kind of ideas are out there to continue with that? And if we look back about these ideas around WebAssembly, it's hardware independent and it's platform independent. And the most important there is the platform independence. We've been running this on the web right now, using this glue there, but that can be anything. WebAssembly doesn't have to use the browser, it doesn't have to run in the browser. It can be whatever you want. It can be the operating system directly, if you have an operating system which supports WebAssembly. It can be some kind of cloud service which has an API like create container, destroy container, that you can have a WebAssembly container running that. A light bulb. Do you want your light to be controlled by some kind of program, and your light bulb understands WebAssembly? Just give it a WebAssembly program which controls your light bulb, and now you can party all night. And probably the most interesting of these is Microsoft Flight Simulator. Because they want a safe way that you can create plugins, like create new planes, create new interfaces, create mods for a game, which needs them to be able to actually turn a profit. But they don't want you to allow you to just write random code that will run on someone else's machine. So using WebAssembly instead, which they create an interface like, oh, if you want to make a new screen, yeah, you can do that. They define exactly what you can do, and then you can just distribute all these plugins of WebAssembly, run them safely, it works. It's a bit weird to say, but WebAssembly is actually neither web nor assembly, is the famous quote. And this is even just the beginning, because there have been very strange things which I found on the web that run on WebAssembly. I found an x86 simulator, so now we can run any x86 program, which means, wait, we can now start using Linux in the browser. So you can actually just run the whole of Linux. They even made the graphical interface work. I don't know how they did that. And if we can use Linux in the browser, we can start a browser in Linux in the browser, which you can actually run x86 again. And Linux, okay, but we can continue on. You can also, there's also a port of SQLite, which runs in WebAssembly, not even a port, officially supported version, which runs in a browser. So we can use SQL in the browser, which means, what if we just, instead of making an actual offline web app, we can just export our backend to WebAssembly, make some kind of glue that connects everything together, add an SQL database to that, and suddenly we have an offline app. Terrible idea, but it would work. And probably my favorite project that I found that actually uses WebAssembly is one to bring back Flash. Ruffle. This is a program that finally makes it possible again for us to go back in time to 2005, or I don't know when you guys were young, and start playing Flash games again. And I'm going to open it right now. They even have a demo. Oh. And your old favorite Flash games finally work. Yeah, I'm not going to play the whole game. That's going to take a long time. So, should you start using WebAssembly? Almost. Because this all looks really cool. I've given some arguments at least, but at some point I thought, okay, let's make a JavaScript version of my 1.6 million tweet reader. So I did. The JavaScript version. This is basically the exact same implementation, exact same type of code. It reads my tweets, it searches through the tweets, and I can query the tweets. And I can just simply replace the code here. Serve that. This should still be running. I can again open my 240 MB file. Oh. The Chrome developers have done a really good job. And this is partially because my Rust code was actually kind of terrible. There's a lot of copying. But this does mean that you don't need to use WebAssembly for everything. There are certainly operations, very expensive operations, which are very good to start using WebAssembly for, to port to. But this glue, which I'll show you, makes things a lot slower. It means that a lot of memory copying is going on whenever we talk between the real world, the DOM, and JavaScript. It's a kind of overhead, and it costs something. So if you have an expensive operation which can run in the background, then that's very useful, but it doesn't mean it's not much faster than JavaScript, or not for this application at least. And next to that, I've shown a library, which for me at least looks really good to start writing a website in. But this is still a very early days for that library. And that means that every time a new version comes out, it turns out we have to rewrite the entire stack. Oops. So for playing around, yes, please start using WebAssembly. It's really cool, and you can use whatever language you like. We can finally start using your favorite language in the web. But for now, let's just play around. Thanks for listening. That was my talk.